Great. Thank you all so much for coming. I'm Carrie. This is Gino and Liz, and we're from the Windows Shell engineering team. We'd like to welcome those in the audience, our webcast viewers, and our Channel 9 viewers. So we hope you had a chance to see Continuum in the keynote yesterday. All the buzz and everything's just making us giddy, and hearing the feedback from you is really wonderful. Our team feels just incredibly lucky to be working on what we think is a game-changing experience for phones. We've worked incredibly hard to pull together some demos today that you're going to get to see. It's the first time we're showing live code. So today we're going to give you an overview of Continuum and then some consideration for you as developers. So I know there's one thing in here that we all share, and that's our love for phones. It's always at my side. We sleep next to them, we take them to the bathroom, they're our favorite dinner date. In Japan, they had to create waterproof phones because 90% of teens would not take a shower without their phone. And phones are very powerful. The processing power of a phone is rivaling that of a desktop PC. But even with this processing power, sometimes it's just not enough. Phones are great when you're on the go, but the phone form factor can be too limiting. So here in Excel, you can see my reporting spreadsheet, and I can pan around and I can see the details, but because of the screen size, it's difficult to get the whole picture. And we've all had times where we had to write a long email or edit a document, and we wish we had a keyboard and mouse. And so this is why we created Continuum. Continuum is part of the Windows operating system. It enables a Windows phone to power a PC-like experience for Windows apps. So you can imagine walking into a dorm or home office and docking your Windows phone to a display, a keyboard, and a mouse. So what you see here, this is not a PC, but the phone is powering both of these screens. And Excel here is a Windows app that is scaling to the screen size and showing its adaptive layout. One of the things that we love is that the phone can continue to be a phone. So even when I'm using Excel, I can still use my phone for other applications, for texts, for phone calls, whatever. So Continuum, it allows you to have two apps, one app on your phone, one app on the connected screen, both being powered by your phone. Windows apps scale beautifully among these screens. And when you want to input with them, you can use keyboard and mouse, or a controller app that we designed to be a software touchpad. So if you build a Windows app and it runs on Windows Mobile, and is designed to adapt and respond to any size. In many cases, your apps are just going to work, and you're going to get the value of this for free. So now, I'm very excited to have Gino come up and walk us through a demo. This is the first time ever that we're showcasing our live code.
Thank you, Carrie.
Yep.
Thanks, Carrie. Thanks to all of you in the room and those of you online. It's a privilege to be able to present to you today. So if you watched the keynote yesterday, you saw Joe present a simulation of Continuum for phone. And to be quite honest with you, over the past week, there's been a couple of days where we thought we might be showing you that same simulation in here. But our developers in Redmond worked really hard to put together a good, solid build, and we're really excited to share that with you today. Keep in mind, though, this is live code. This is a work in progress. There's some rough edges that you'll see. There's some glitches that I'm sure will come up during the demo, so keep that in mind. Bear with us a little bit. Now, before I get started, I've seen a lot of questions online over the past 24 hours about the accessories. Did this feature require any specific hardware or accessories in order to enable it? And the answer is no. As a matter of fact, for this presentation, what I have here is this is a wireless setup that I'm doing, and I have a Windows phone, obviously running Windows 10 on it. I have a Bluetooth keyboard and mouse that are paired with the phone, and I have a Miracast receiver. This is an ActionTech ScreenBeam Pro Miracast receiver. Okay, so let's get started. Let's say I get a text message from a colleague and they want me to update the number in our budget spreadsheet. So no problem. I'm actually going to copy that number to the clipboard because I'll use it later. Now, I have Excel on the phone, of course. And I could go ahead, there's the file. Not easy when you got fat fingers. All right, wait a minute. Let's try that again. Oh, that's why we bring a backup device. There we go. Actually, there we go. Sorry about that. Told you there'd be glitches. I warned you. Okay, so this is Excel on the phone. Now, it's a universal Windows app, so it scales down. This is the small screen, the phone form factor and layout, of course. But as Carrie said, this is kind of a dense file and be a little bit difficult to work with this on the phone. It'd be much easier to work with it on the big screen with a keyboard and mouse. So let's go ahead. I'm going to get this square for you guys. Let's get connected. I'm going to dock my phone here by opening up Action Center, clicking our new Connect button. There's my screen beam. I'll click that, and voila.
All right.
Welcome to Continuum. And I know this is going to sound really cheesy, but welcome to the future. So this is my phone's start screen, right? It's exactly as I've customized it. My apps are in a familiar location, and it works great with mouse. Bring my mouse over here. I can scroll up and down. I can use right-click to customize it. There we go. I can do all the things that I'm used to doing on my phone with Start. And look in the upper left-hand corner here. There's my network strength icon. Over on the right is my battery icon and the clock. This is my phone, and this is my phone powering a second screen. But over here, if you bring your attention to the phone part of the picture-in-picture, I can go back, and there's Excel. Excel's still running there. Okay, so let's have a little fun here. Let's open Excel. We're going to bring it over to the big screen. I simply go to Start, click that, and there it reflows. So all that happened there was Excel received a window resize event and reflowed for the second screen. And look, this is Excel as I'm used to using it on the Universal Windows app on the big screen. It looks great. It works great with keyboard and mouse. And let's see, I want to go ahead and make that change. So keep an eye on the charts here. I right-clicked. I'm going to paste in there. Everything refreshes. It works just like Excel. This is a great thing about Continuum and about Windows apps is I have one binary, and I can design that to flow and rescale for different form factors, but it's one binary across all form factors. All right, so now I can continue to be productive here with my keyboard and mouse, but let's say I'm done working, and now I want to go downstairs and watch a movie on my TV. I have a Miracast receiver connected to the TV in my living room, so I can sit back on my couch and I can stream from my phone. But I don't have a keyboard, I don't have a mouse down there. So as Carrie mentioned, for that, what we built is the Continuum controller app. Now, if you look at this blue bar across the top of the phone, it says that I'm connected and it says tap to control. I'll go ahead and do that. And this is the controller app. Now, we're still working on this. It's still a work in progress here. But this operates just like a trackpad. So I'm going to go ahead here, and if I move my finger around on the screen, what you'll see is the mouse should move. Like I said, we're still working on this. It will move on the external screen. I can tap on icons to open them. I can tap on items within applications. If I tap in a text field in an application, the keyboard on the phone will come up, and I can enter text there. That will then be routed directly into the application running on the external screen. So last thing I'll leave you with is let's take that movie watching scenario and run it all the way through. I'm going to go and open our video app. And I have a video in here. There we go. We just posted this online yesterday. Let's do that on the external screen. Okay, there we go. Make sure I got sound turned down on this. Joe had his chance to speak yesterday. There we go. Okay, great. Look at this. It's an HD video. It's streaming really great to the external screen. It looks awesome. And now let's see what I can do on the phone. I'm going to go to Start. I might want to check my calendar. There that is. It's Outlook Mail app. Look at the video on the external screen. It's still running. If this were a child's video, and if you have kids, you've probably seen those the videos your kids like about 50 times. So it's great to be able to stream that video, check your email. Let's open email. Check it out. Not bad, huh? Now, I know what you're thinking, and I want to say we can do this with streaming video over the web, and it's still just as rock solid. It's great. All right, folks, that's a little brief overview of Continuum. Thanks, Carrie.
Great. Back to slides. Great. Thank you so much, Gino. We did it. Great. That was super fun for all of our team out watching. It was fun to show. All right. So Continuum is a really important feature for Windows 10. Our vision is to enable a PC experience for everyone on every screen. In developed markets where people have PCs, it's much more around flexibility and convenience. If you leave your laptop at work or you're just too lazy to bring it home, you can be confident that you can get your work done if you need to. And this is what we're delivering for Windows 10. In emerging markets like China and India, the smartphone is the first and only computing device for many people. So you can imagine if you're a student and you have just one computing device, it will be a phone. And you know what? Likely, you also have a TV. So now you can imagine taking your Windows phone, connecting it to your existing television, adding a keyboard and mouse, and having a PC experience, maybe for the first time. We know from our research that this is really a game changer. It was really impactful when we brought these scenarios to those markets. And this is the roadmap for Continuum. So we talked today about how Continuum can light up a display and a keyboard and mouse. But we actually envision a world where the phone powers many more screens and experiences, where every screen can become a PC. So Continuum enables a new class of low-cost, flexible hardware that can be powered by the phone. So what you're seeing here, this is not a laptop. This is a display and a keyboard, and there's no processor inside. The phone is powering this device to be just like a laptop. And here you can imagine taking away the keyboard and having a tablet. There's so many other ideas that we have. So one of the other great things about these devices is that they can be shared. So for example, in my household, I could be using this device, and then my husband can pick it up and can use his phone to power it and have a personalized experience with his apps, his data, his services. And my son can pick it up and use it for homework. So we're really, really excited to talk about how Continuum scenarios might light up your Windows apps. And I'm going to invite Liz to come in and talk about the considerations for you as developers.
Thanks, everyone. It's really awesome to be here. I'm so happy that our demo actually worked for you. Now I want to take the rest of the time to talk about what you as developers actually need to think about when developing apps that run on Continuum. So we have a bunch of developer considerations. Only about 3 of them are really integral to your success. And then we have a couple other topics we just want to show off and get you thinking about. But before we talk about those, I want to make sure everyone's grounded in the 3 hardware configurations that will be available in Windows 10. So the first configuration is a wired dock. You could think of someone going home, sitting at a desk in front of a monitor, keyboard, and mouse to be productive. Now, in this configuration, there's a dock that serves as a hub for these 4 accessories: the monitor, keyboard, mouse, and phone. The keyboard and mouse are plugged in via USB to the dock, or they can be paired via Bluetooth to the phone itself. Now, the big benefit of this scenario is that because the phone is actually plugged into the dock, your phone will be charging while using the external screen, and you'll get the best performance possible. Now, I know a lot of people prefer wireless configurations, so you can also have the same productivity-centric scenario with a wireless dock. The main difference between this and the previous scenario being that instead of plugging your phone in, you just connect via Miracast. So our final configuration is a wireless dongle. You can think of someone going home and lounging back on the couch with friends and family. And instead of using a keyboard and mouse to power the external screen, we actually expect people to use their phone with the Continuum controller. Here, you can enjoy videos, music, photos, any other Windows app that you want on the big screen. And the big benefit of this is flexibility. You can take your phone and power any screen on the go and navigate it with our application. So I think the most important thing for you as a developer to remember is that users will interact with your Windows apps on big screens with a keyboard and mouse powered by a phone. All right, so the one thing that's really going to help you be successful on Continuum is building adaptive apps. Now, I'm not going to go into a bunch of detail on our Windows scaling model and effective pixels, but it is integral to your understanding of building adaptive apps. Effective pixels are a virtual unit of measurement that we use in Windows to describe the size of any display. The effective resolution of a device is determined by a combination of the actual theoretical physical pixel density of that device and the theoretical viewing distance that the user would be standing from it. The big benefit of using effective pixels is that you as developers can design and build your UI one time, and the Windows system actually does a lot of work on your behalf to make sure that UI looks great on any screen. I would make sure that you go and reference some sessions on effective pixels after this. So developing for Continuum really means making sure your Windows app adapts dynamically to any screen from a phone. In our configurations, we really expect for users to see phone-optimized UI on the phone and big screen optimized UI on the big screen. Now, when we think about adaptation, we think about it in three kind of building principles, the first of which is called fluid UI. Now, fluid UI is all about building UI elements in effective pixels and positioning those UI elements relative to each other and the container that they're in on any screen. This is kind of the foundation of building an adaptive app, and if you do this, you should get some default behavior for adaptation on Continuum. So, given a window size change, your app should be able to resize to any screen. Here you can see that as the screen size shrinks, the content in the screen actually resizes to better fit the space that it's in. You can also use wrap grid style controls to reflow and wrap content based on the width that's available. You could wrap text, images, tiles, or any other kind of grid-like structure. So let's look at a more concrete example. In this view, we have three main UI elements. The first one on top is just a photo that always spans 100% of the width of the screen. Then there's an element in the bottom left that spans a third of the screen, and an element in the bottom right that spans 2/3. So this view was designed only with percentage-based layouts, and the content is either right justified or left justified to the container itself or to other UI elements. This means that when the window size shrinks, this app can adapt really easy and naturally to any screen size. So to actually do this on your own, you should reference the relative panel class. This class will help you position your UI elements on any screen relative to each other and the container. Using this class, with percentage-based layouts and things like wrap grid controls, will give you a fundamental scaling experience on any screen. All right, so the second, if you want to do a little bit more work than just that basic fluid UI, you can use responsive UI. And this is all about revealing and morphing and repositioning UI at specific snap points. Now, a snap point is a trigger that you use to actually snap between two different UI layouts. For Continuum, we suggest that you use a snap point of 768 effective pixels. This seems kind of arbitrary, but it's actually kind of the line between what devices we consider to be a phone and what devices we consider to be larger displays or not phones. So for any device that's less than 768 effective pixels, again, the user should see phone-centric UI. And for bigger screens, large screen UI. So responsive UI is all about using adaptive triggers. You can use adaptive triggers to reveal content at specific snap points. Here you can see that as the screen shrinks, a button emerges that's very custom for the phone, and it's only relevant on phones. You can also reposition UI. So in this example, as the screen shrinks, UI element A and B condense a little bit, but then at a specific point, they become too narrow. So at this point, UI element B actually snaps off the side and moves down below UI element A. Let's look at the same example. So at some point, if I shrink the screen a little bit too much, what's going to happen is this is going to become unusable. The two columns are going to have weird one-line text fields. So instead of just shrinking it, at a snap point, it's actually beneficial for the developer to just break off that right-hand bottom UI element and wrap it along the bottom. So let's take a look at an example of using an adaptive trigger. In this example, a developer wants to show a wide button on big screens and actually exchange that button for a narrow button on small screens. So if we focus on the top, this developer is using the adaptive trigger of minimum window width to say, OK, if the screen is greater than 768 effective pixels, show a wide button. And if it's less than 768 pixels, show a narrow button optimized for the phone. Now, this adaptive triggers can be used in many ways and with many different types of triggers. This is an example of using minimum window width, but you could also imagine using input type or device family or some other custom trigger. So finally, if you really want to optimize your application for any screen, you can use tailored UI. Tailored UI utilizes the same adaptive triggers we just discussed, but in more complex scenarios. We generally expect developers who really want to tailor their experience to actually tear down and reconstruct their app either with new views or new navigation models across screen sizes. For example, you can replace controls or UI elements as at a specific snap point. In this example, the big screen view is pretty desktop-centric. You can think about it as being pretty dense and needing a keyboard and mouse to navigate. But below a set snap point, you really want to optimize for touch on a phone or tablet. So the UI elements actually lend themselves to that by switching into a scrollable list. You can also just re-architect the entire navigation model and layout of your application. In this example, on the big screen, the application has a two-column view, column with a list, and then a column with a reading pane. And as the screen shrinks, that actually switches to a single column view to optimize for screen size. As I said, you can use literally the exact same adaptive triggers to build tailored UI. It just is growing in complexity. All right, so I'm actually going to switch over and show you guys a couple of adaptive apps in action. Hopefully, we will have some demoing abilities again. Good. OK, so I'm actually going to take a look at the weather app. So the weather app is a really good example of an application that uses very basic fluid UI principles to make sure that they adapt to any screen size. So here you can see that it's 82 degrees. I'm kind of sad I'm not outside. There's a weekly preview of the weather, some charts, and then details. Now I'm going to go ahead and move this app to the big screen. Lovely. OK, so you can see that it actually reflows really nicely on the big screen. It's pretty sweet. So I can show you guys side by side, I'm actually going to pull up another phone and with the weather app already on it so I can show you what's going on. So if you look at these two devices, the UI looks essentially the same. And it appears to be the same size on both screens. It appears to be the same size because the developers used effective pixels to actually build their UI elements and their fonts. So the system, on their behalf, does work to make sure that the UI looks great across all screens. They do a lot of good stuff with resizing UI elements. So they resized this window where the day of views are so that on a big screen, you can see more days, say 8 or 10, whereas on the small screen, you have to scroll. And then if I navigate down to this details list, go over here, you can see that on the phone, it's just a simple list of details. But on the big screen, where the screen's much wider, they actually wrap those details horizontally using a wrap grid style control. So let's take a look at a couple more apps. I'll pull up Outlook Mail. Now, Outlook Mail is a good example of an app that actually changes their navigation model at a specific snap point. Reminder, the phone I'm showing is not the phone powering the external screen. Oh, give that another go. I'm just using it so I can show you guys the app side by side. Lovely. So, perfect. So this is Outlook on the big screen. Very similar, identical to what you would see on desktop. So as you can see on the phone, Outlook has this single column view where they actually just have either the reading list, the mail list, or I can select a mail, go in, and it will load just in that mail. You can see on the big screen, when I have that same mail open, it actually reflows, and you can see the 3-column view. So Outlook uses specific snap points to determine when they should show one versus multi-column views. For one last demo, I'll switch over to Outlook Calendar within Outlook. Hopefully this will work for us. Lovely. So Outlook Calendar on the phone is really optimized for just checking out what you're doing today or what you're doing next. They kind of assume people are on the go and just want to see what the next appointment is. So here I basically can either look at my agenda or I can look at my day. Now on the big screen, they actually have, well, hang on, let me try this again. Bug Central, yeah, you set that up. On the big screen, they make available, they theoretically make available the month view, the week view, etc., because they really want you to be able to take advantage of that big screen in the best way possible. So we'll go ahead and switch back over to the deck. Lovely. Great. So now we've talked about building adaptive apps. Let's talk about the different ways that you can package your Windows apps such that they work well on Continuum. If you build an adaptive Windows app that runs on Windows Mobile, your app will have some default behavior on Continuum. Now, there's 3 main ways that you can package your app such that it works. The best thing you can do is just build a universal Windows app with a universal Windows app package. If you do this, we're generally assuming that you're building an app that's going to adapt across all screens and device families. So you're already doing everything you need to do to work on Continuum. Your app should just work. The weather app that I just showed is a really good example of an app that built a universal app, and it just worked in our scenario. They had no idea Continuum was even a feature when they were building their application. Second type of app package that's compatible with Continuum is mobile-only apps. So we know a lot of developers are mobile-only developers, and they're really focused on the phone and their phone app. And that's totally fine. Now, the thing that we do ask you to do is ensure that you've built your mobile apps with fluid, responsive, and tailored UI, such that they actually do have some dynamic reflow. So if you want to do a little bit of work, you can use these adaptive principles to further optimize your app. Some of these optimizations are things you have to do anyway, just to make sure that when the orientation of a phone changes, that it adapts in the right way. So they'll benefit you both on the phone and on Continuum. Now, if you discover that you really want to optimize your mobile app for Continuum, you might as well just think about building a universal Windows app, because you're already doing a lot of work to optimize your big screen views, and that work could be seen across all Windows device families. So let's take a look at a couple of mobile-only Windows apps and see what they look like on the big screen. I'm going to switch over to my phone. Lovely. All right, so on my phone, I have the Photos application. And this is a mobile-only application. It's not a universal Windows application. And you can see here that I have my photos. They look lovely. So I'm going to go ahead and move this over to the big screen. See where it is? Lovely. So you can see here that the Photos app actually has used wrap grid style controls to ensure that the photos reflow nicely in both orientations on the phone. And that work paid off on the big screen because the apps now reflow and wrap properly to that screen width as well. So I can also go ahead and open an app here just for fun. GoPro photo, see full screen image. We're having fun at Build. I hope you guys are too. OK, so now I want to show you one more app that actually did a couple of very small tweaks that make a big difference on the big screen. So File Explorer is another mobile-only application. And it's basically, there's two options. You can see my recent documents, or I can see all the documents on this device. This is very similar to the kind of information I would see on the desktop. So I'm going to go ahead and move this to the big screen as well. Watch start. Lovely. So whenever it moves, the folders actually just use a similar wrap grid style control, and so they reflow nicely to the big screen. Now, the thing I want to point out is that on the phone, the File Explorer actually had a tab menu that was hiding that those recent and this device options. But on the big screen, they opt to just leave this open permanently, which is much nicer for a desktop keyboard and mouse user. OK, we'll switch back to slides. So we've talked about developers who have universal app packages, developers who have mobile-only app packages. Now I want to talk about the developers who have both mobile, separate, but both mobile and PC app packages. Now, by default, we won't have any concept of your PC app package on Continuum, because it won't even be on the phone. So generally, if you do no work for Continuum, we'll just see your mobile experience on the big screen, just as if you had a mobile-only application. Now, if you want to do a little bit more work and leverage the work you've done for the desktop, then it's up to you to actually pull assets or views from your PC application into your mobile app package and do the work to switch between them. Here's a really simple example. Basically, you could think of it think of the logic as, hey, if the screen size is smaller than a phone, use my phone view. And if you want to pull your PC view in, you can use that PC view on larger screens. Now, obviously, this is very simplistic, and you probably would want to do things like save your app state and make sure you're refreshing content correctly whenever you switch views. So we'll go back to the phone and look at another example of what this could look like. All right, so here I have Microsoft Word on the phone. You can see I have my Word document. Thanks, Gino.
There you go.
So I have my Word document. I could edit it here if I wanted to. And the main difference between Office on the phone and Office on the big screen is the controls. So instead of the traditional desktop ribbon that everyone's used to, I can actually use this bottom control to change things like my fonts, my colors, insert images, or do anything else. And this control is really optimized for touch and thumbs and doing things on the phone. So I want to actually move Word over to the big screen. Ta-da! Awesome. OK. I love when Office is on the big screen. So what Office does when it moves between screens is basically the first thing that happens is Office gets a window resize event. And when it gets that event, they have to make a decision if they're going to keep showing the phone UI or if they're going to actually exchange out those assets with the more desktop-friendly UI. And so if they decide to actually exchange those, then they need to tear down their old controls, save state, and reconstruct their app with the new controls, just like they did here. Now, Office is a really good example of an app that uses both tailored UI and very basic resize principles. The document itself actually just resizes to some percentage based on screen width. There's nothing really fancy happening with it. So we'll go back to the slides, please. All right, so how do you test your applications on Continuum? So generally, we expect that your applications will respond and adapt given only a window resize event and based on the width of the screen that it's on. So really what you can do is just test it on the desktop. Because if you resize your window on a desktop, then you'll get exactly the same events, the same things will happen as if it was moving between screens on Continuum. if you're successful when you resize your window on desktop, you should be successful in our scenario. Now, this is a bit nuanced. Obviously, if you're using more complex triggers, you would have to develop test hooks to actually test your application. OK, so let's talk a little bit about scaling. And by scaling, I mean, how do you make sure that you have the right assets to make your app be pixel perfect on any given screen? And the reason this isn't integral to your success on Continuum is because our phones today have very high resolutions. And so any assets that you provided for the phone will actually look pretty good across any display size. But we'll still dive into detail. So as a developer, you need to think about how your apps scale to the big screen. Again, a background in effective pixels in the scaling model is key to truly understanding this. So you should reference those sessions. So every Windows device, every device in the Windows platform is associated with a specific scale. And this scale is derived from the effective resolution of the device. And remember, the effective resolution is computed from a combination of the physical pixel density and the theoretical viewing distance of a device. So in our scenario, the most common kind of scales are going to be a phone will have a scale of about 300, a monitor typically has a scale of 100, and a television typically has a scale of 150. So you can see that there's not really necessarily a direct correlation between screen size or form factor and scale. It really does depend on that physical resolution and the theoretical viewing distance, or how far the screen is from the user. So, and also, these scales are used by the resource management system. And the resource management system basically looks at all the assets you provided in your app package and picks the right ones for any screen. So let's take a look at how scales work in Continuum. As I said, a scale of a phone is usually about 200 to 400. 300 is a good number. And the external screen that the phone's connecting to will typically have a scale between 100 and 150. So by default, only scale assets for the phone will actually be deployed to the phone, even if you made more assets available in your app package at first. The resource management system tries to minimize the number of assets that go onto any given device, but also optimize for whatever screens are actually connected to that device. So if the phone has a scale factor of 300, then by default, only scale 300 assets will ever be deployed to that device. Yeah, and that sounds problematic at first, because monitors really want to be at a scale 100 or a scale 150. So at first connection, or by default, you kind of get this experience where, that should say 300, sorry, where the phone and the big screen are both scale 300. But if you do work to make assets available in your app package for, say, scale 100 and scale 150, then the resource management system will actually do all of the work for you to make sure that those correct assets wind up on the right screen at the right time. You don't have to do anything but provide the assets for it. And I will note, to save space, if the user doesn't reconnect to the screen within 30 days, then those assets will be removed from the phone and re-downloaded if needed. So if you don't provide assets, you basically run the risk of your assets not scaling correctly or not being pixel perfect on any screen. And the worst case scenario for Continuum is that your assets will be downscaled. We can basically guarantee this because we know our phones have very high resolution screens, and all the monitors and TVs that you're connecting to will most likely be either the same resolution or a lower resolution. So whenever an asset's downscaled, the system is essentially taking one of the high-resolution images you provided for the phone and scaling it down to the lower resolution of the connected monitor or TV. So when this happens, the icons basically become not pixel perfect. They're compressed. But in reality, they won't really look that bad. The average person probably can't really tell the difference between this compressed image and the pixel perfect image. So that's why it's not really integral to your success in our scenario. But in case you do want to be pixel perfect, here's how you actually go about adding and referencing scaling resources. You can add scaling resources in one of two ways. First, you can add new assets to an assets folder in your app solution. You add them with the nomenclature of name.scale-xxx for whatever scale you're using. And you can just throw all of your assets in this one folder. And if you use this nomenclature, the system will find the right assets at the right time and put them on the right screens. You can also have scale-specific folders. So rather than putting all your assets in one folder, you can actually just put the same set of assets in different scaling folders. And again, the system will do the right thing to grab the right ones on the right screens. I will note that you can actually mix and match this organization system. You could have scale folders and an assets folder, and the system will hunt through all of them. You can reference your resources with a URI, leaving out the scale-XXX. Again, the system knows what scale it's looking for, and it knows how to find it. So an example, an image tag in XAML could look something like this. And this is really, you're referencing the logo image that's in your asset folder. And based on whatever screen you're on, the system will go and find the best scaled image for that screen. All right, so we want to leave you with one final scenario. You have developers have the ability to take advantage of both screens in this scenario simultaneously. There's a handful of APIs for this, and there's actually a session later this evening called screencasting that you should attend if you're interested in this. But the multi-screen APIs essentially allow you to take advantage of both the phone and the external display simultaneously for basically creating any sort of robust multi-screen experience you want. I'm going to highlight two APIs here that work really well with Continuum, and again, I encourage you to go to their session. The first API that's available is the Cast API. This API allows you to take a media element from your application on the phone and put it on the external screen. Now, what's happening when you call this API is the system is creating a view on that screen on your behalf, taking your media element and just putting it there. This is the easiest thing for you to do as a developer if you have a media app and just want to get media on the external screen. Now, if you're not a media app developer, you can use the Projection Manager API. This will allow you to create two completely customized views, one on the phone, one on the big screen, and basically do whatever you want to do with those views. Note that if you use this API, you have to remember that you are the only form of control that the user has on the external screen. So whatever view you have on your phone needs to be able to provide input to the external screen. Yes, we'll have our Continuum controller, but we don't want the user to have to leave your app to navigate what view you put out on the external screen. So let's take a look at how you would actually go about using the Projection Manager at a high level. So the first thing you do is just start by checking whether or not there's even a device connected. If there's not, you'd have to handle it as a single screen. But if there is, you can go ahead and create the view that you want to put both on the external screen and on the phone. At which point, and then once the view is created, you can call projection manager.startProjectionAsync to show your new view on the display. And then once you're done with the multi-screen session, you can call stopProjectionAsync, and the multi-screen session will end, and your app will return to the screen that it originated on. All right, so one last demo for you guys. Hopefully, we will be just as successful as before. I'm actually going to switch over the phone. Great. So here I have PowerPoint. And historically, whenever people have done slideshows from their phones, they've wound up in this state where the slideshow is actually mirrored across the two screens. I see my slides there, and I see my slides here. So PowerPoint has actually utilized the Projection Manager in a new way for Windows Phone. Go ahead and start my presentation. Awesome. So now you can see that instead of seeing the mirrored thing, where I see the slides on both screens, I actually see not only the slides on my phone, but also my notes and the slides that are to come. And I can really easily just slide between these. Oh, no, I'm going back. You guys got to see that animation. So you guys, I can really easily go through here. You can see that the animations are crisp and clean. It looks great on the big screen. And my notes are readily available for me on the phone. I'm an expert in biochemistry. All right, so I'm just going to go ahead and finish up the presentation from my phone because it's already connected with just some calls to action for you guys as developers. Now, our main call to action is just that we really are asking you to build universal Windows apps or optimize your mobile apps for Continuum if you aren't ready or don't want to build a universal app. Now, there's a couple of ways you can optimize your mobile applications. One, you can just use the adaptive principles we discussed to make sure your UI reflows nicely to any screen. Or two, if you have PC assets available, you can actually do the work to pull those assets into your mobile app package. Once you actually have an app package, you should validate that your UI looks good on the small screen and the big screen. We don't really care how you implement it, how you switch to what shows on each screen. We just want users to be able to interact with it and enjoy their experience. Also make sure it works with keyboard and mouse, as that will be supported not only on Continuum, but on phones in general now. Now, if you want to be pixel perfect, you should also think about including additional scaling assets for the external screen. For Continuum, there's really two scales that are important: scale 100, scale 150 for the monitors and TVs. And finally, if you want, and you have applicable applications, you should leverage these multi-screen APIs to actually create robust multi-screen experiences.
So we just wanted to say thank you so much for coming. We are just super excited about Continuum and the scenarios that it's going to drive in the future. We will be here for questions afterwards. And yeah, thank you very much.
Thanks, everyone.